Hey guys, today we're going to look at square roots. We're going to try calculating and comparing them. So we're going to start with the definition of a perfect square. And a perfect square is going to be an integer squared. So I'll list a few off. We start with 2 squared, which is 4, then 3 squared, 4 squared, 5 squared, 6 squared, and so on. So this list is a small list of our perfect squares starting from 2 squared all the way up to 15 squared. Another way to think about a perfect square is if you take the square root of any of these numbers, it will come out nicely with no decimal. Okay, a couple more definitions. When we talk about square root, know that that is the symbol we're going to use. And then in a square root, we have a radicand. So it's the number inside of that square root. So for example, here 54 is our radicand. Another word for a square root would be a radical. And we are going to get questions similar to this one. So is 54 a perfect square? Meaning, based off our definition from before, when I take the square root of it, will it come out without a decimal? Well, you can think, we know 7 squared is 49 and 8 squared is 64. There's no integers between 7 and 8. Therefore, 54 is not a perfect square. Okay, I want you guys to answer the question, is 16 a perfect square? And please explain your answer. All right, next we are going to estimate some square roots. So we have square root of 50 and we need to estimate it to the nearest integer. We know it's not going to come out, it's not a perfect square, so it's not going to come out nicely. Therefore, that's why we estimate. So if you think closest perfect squares would be 49 and 64. And 50 is a lot closer to 49. We know the square root of 49 is 7 and the square root of 64 is 8. So we know it's going to be somewhere between 7 and 8. But like we talked about, 50 is closer to 49. So we know the nearest integer would be 7. Okay, I'd like you guys to please estimate the square root of 90 to the nearest integer. Okay, another example, we can simplify square roots and then compare them. So square root of 4, square root of 36, both are perfect squares. That comes out to 2 and 6. Likewise over here, perfect squares come out to 3 and 5. When we add 2 and 6 on the left, we get 8. 3 and 5 on the right, we get 8. Therefore, our two expressions are equal. One last example. We are given the area of a square dance floor. We know that dance floor has an area of 289 square feet. And our goal is to figure out what's the side length. Well, if you think about a square and the area of a square, we know that we take length times width. But in our case, since the length and the width are the same, we have, I'm going to use S for side times side, which is side squared. And we know our area is 289 square feet, so we can substitute 289 in for A. I guess I'd go there. We have S squared equals 289. Now, the opposite of square, to undo that square, is to take the square root. So our side length is equal to the square root of 289. And now we want to know, is 289 a perfect square? And it does indeed come out nicely. Therefore, in this example, the area of the side length of our dance floor would be 17 feet.